Whoa, hey! I didn't see you there. I'm in focus now. Stinky. Okay, you can see my face now. Alright. We're getting started. So, I made a rocket engine. Isn't that cool? I haven't tested the rocket engine. That's going to be in another video where I'm going to amazingly struggle on figuring out how to fuel my rocket engine. But first, we must build this magnificent engine. First step is to get a graphite rod. You can go to McMaster and somewhere else in the world, probably. Graphite rod that is... I need more hands. That is exactly 20 millimeters. Wow. Alright. And that's right, I use metric. Get out of here, you Americans. You American nerds. Anyway, you get that rod, and then you need to cut it. I cut it around 23.5 millimeters. That worked out the best for me. But you can cut it longer if you want. You know, it's a free country that I live in. Then after that, you're going to want to steal a drill bit out of your mom's garage. This drill bit, it's a 90-degree angle, at least close to 90 degrees. It's more like 80 degree, but as long as it's really close to 90 degree, then it's good. And once you have the graphite, you want to drill it to where it reaches all the way to the very edge, and it's evenly around the edge, so that the point of this drill bit is centered on this graphite rod. Make sure it's cobalt drill bits, like these ones. Pretty nice drill bit. Drill pretty well through graphite, and make sure when you're drilling that you have a fairly low RPM so that dust doesn't just kind of everywhere into your lungs. Then you're gonna want to drill the main part of the nozzle, the throat of the nozzle. And I use about a 5 millimeter drill bit, this one. And then after that, you're going to want to make your own drill bit, like this. And sorry, I didn't make a video about this one. Or buy a drill bit that's already at an angle of 35 degrees. I made this one from an aluminum tube and steel that I stole from the side of a computer. You're gonna want to take the 30-degree drill bit and then drill it on the bottom side of the nozzle, the opposite side of the 90-degree, until you reach a decent portion of the way through, maybe like half of the radius of the nozzle. I kind of just guess, and that usually works pretty well. Then after that, you're going to want to buy a slab of O-ring material. It should look like this. It should be a little small plate of silicone, and it's about 3 millimeters thick. Now, you're going to cut a square of that. You're going to attach it to the drill press, and then once you do that, you're going to get an X-Acto knife blade, which you're going to set it up in a vise on the bottom. Then you're going to mark the center, then get your fancy dancy caliper and measure out 12.8 millimeters. And then you're going to notch a little circle, and then you're going to mark another one that's 9.9 millimeters away from the center. Then you're going to cut that out. You should get an O-ring that looks like this. Get your nozzle, you find a way to attach it to a drill press, then you get a metal file like this one, and then notch a little area of about 3 millimeters thick, the thickness of the O-ring material, and you're gonna make 2 of those actually. Try and make them as close as possible to the top while still giving enough room to have it not break. And after that, you cut a piece of copper. You get the copper, then you do the magical hammer hit. It takes many years of practice to know this, but once you get it, it's very reliable. After that, you get a cap. Oh, by the way, the copper tube is 3/4 inch. After you solder the cap, and sand the cap, clean it, put the flux on, get the propane torch heated up, put the solder in place. You then get a copper coupler, 3/4 inch, of course, and cut a segment about 10.2 millimeters long. Then you sand it down, of course. Gotta sand it down, clean it, put the flux. You put that onto the 3/4 inch and solder it in place. Then you smooth the edge. The edge right there. You're gonna want to smooth it out so that whenever you put in the O-ring, it won't slice the O-ring and do weird things and break it and cause leaks, and you don't want that in a rocket engine. After that, you drill 4 holes, preferably as symmetrical as possible, but I was kind of lazy. Just like, it looks right, eyeballed it, but don't tell anyone. Then get nuts and bolts. Make sure you get the tiniest as possible and consistent. I had to shrink my nuts and use the grinder to do that, but it worked out. And then you get the graphite nozzle and you cut notches. Not the notch from Minecraft, but notches that look like this. They look like this. They should be able to fit the nut right in that little slot and be able to fit into the copper tube. Once you do that, you make sure everything's lined up. I put a little notch on the graphite to line up with the notch that I put on the copper, since I was lazy with the symmetry. And then once I put it in, I put the screws in, and there you have it. Isn't that beautiful? Yeah, that's about it. Next video, you'll see me struggle with fueling my rocket engine, thinking about fuel grains, fueling it directly, melting the fuel, 3D printing things, molds, all these exciting things. And then you'll see the beautiful testing that happens. But yeah, let me know if you like this kind of style of video, and I'll see you sometime in the future. Steel that I stole from the side of a computer.